There's a gauge pressure of 812 torr at a depth of 14.2 meters in a fluid. What is the density of the fluid? Assume there's an atmosphere above the fluid. Okay, there we go. So here's this fluid. The first thing I got to do, by the way, is let's turn 812 torr into pascals, right? So 812 divided by 760 times 1.013 times 10 to the 5th. 812 divided by 760 times 1.013 E5. And I've got 108,231.0526 pascals, approximately, right? Okay, so that is our gauge pressure, right? Okay. Now, what do we do here? Well, I think I'll just use the formula the way it is, and then I'll talk about how we didn't have to do all that work. Okay, so the absolute pressure, right, is the pressure above the fluid plus rho times g times depth, right? And we're 14.2 meters down in this fluid, right? So this is our gauge pressure, right? Okay, so let's figure out the absolute pressure. Absolute is going to be gauge pressure plus 1 atmosphere. So I'm going to add 1.013 times 10 to the 5th pascals, and we're going to get the absolute pressure, right? So plus 1.013, and I get that the absolute pressure is 209,531.0526 pascals, right? So now I can plug that in. That's my absolute pressure. So 209,531.0526 is, and then the pressure above the fluid is 1 atmosphere, right? So it's 1.013 times 10 to the 5th pascals, right? This is pascals. Plus, let's see, the density. Oh, we're trying to find the density, okay. Times 9.81 times 14.2. All right, hold on here. Okay, so now I don't know if you're paying attention here, but I took this number that we calculated after we converted it, right? I added an atmosphere. The first thing I'm going to do here is subtract an atmosphere, so I really didn't have to turn it into absolute pressure. Okay, but there it is, right? Okay, so step 1, subtract 1.013 E5, and I'm back to the same number there, right? Okay, divide by 9.81, divide by 14.2, and I get that the density is 776.9526. With 3 sig figs, we'd say 777 kilograms per cubic meter. Okay? Okay. Now, this thing here, this is our gauge pressure. If there's an atmosphere above the fluid, this thing is our gauge pressure. Okay? So really all I had to do is just go 108,231.0526 equals density that we don't know times 9.81 times 14.2. I didn't have to turn it into absolute pressure, then use a formula that for some reason is in absolute pressure. I could have just taken that number, right? Let's find it. There it is. Divide by 9.81. Divide by 14.2. They give us this complicated formula for hydrostatic pressure, and I thought I'd use it, but really this is pretty simple. 777 kilograms per cubic meter. Ta-da.